This is a presentation of the new features within Alphacam 2015 R2. This presentation will deal with the new features that we've added to the advanced 5-axis module works machining engine. This is not a new command because we first introduced it in 2015 R1, but it only contained basically finishing strategies. Now we're adding options to obviously increase what is available. We've added wireframe machining, which is basically cutting geometries. So it's very similar to the existing cut spline polyline strategy within Alphacam. The geometries can obviously either be drawn if they're simple, or they can obviously be extracted from solid models. We've introduced multi-axis roughing, which is a roughing strategy that will actually follow the contour of the part that you're cutting, which reduces fresh air machining. And SWARF machining strategy. Now this is basically an effective side of the tool machining strategy for finishing a part in one go. All of these strategies are compatible with the 5-axis toolpath optimizer. If we look in a bit more detail now at wireframe machining, it's ideal for trimming of parts. So you get parts, maybe chair seat or anything, plastic trimming parts that you just need to take the flashing off. We can obviously get an edge from the geometry, get an edge geometry from the solid model, and then obviously we are worried about machining the geometry, not the actual solid itself. We need geometries for obviously the drive curves, but also for the orientation lines, so we can get the vector of the tool, i.e. the direction of the tool. So these are relating to the ghost tool, and the direction it points will be the direction that the tool points. And it handles obviously geometries with square corners, so there's no requirement to fillet this for the tool. It will go up to the corner and then move its way around it perfectly. If we then look at the multi-axis roughing, as I said before, this is ideal for the stock removal relating to the actual contour and the profile of the part. We have the current offset simple method, or we can go for the waveform strategy, which allows faster feed rates because you're getting constant material removal. Complex profiles are easily handled. There's no restriction to the actual shape of the contour that you're cutting. And then the swath machining strategy. As I said, this is effective side of the tool machining. So you'd rough your part out, and then this point of this is to basically cut along the part in one go to finish it. And it's obviously following once again the contour. You obviously have options for gouge checking, but it's a very, very powerful strategy, as we'll see in the demonstration. So let's have a look at these parts within Alphacam. So firstly, let's look at how wireframe machining handles a part with square corners and applies a toolpath in general. Let's start by selecting a suitable tool. So I'm going to pick my flat end 6mm, obviously making sure it is defined as an advanced 5-axis tool. And we're going to select the wireframe machining option. We set our speeds and feeds accordingly, and then we're presented with the wireframe machining dialog. If we go to the pattern drop down, we'll find there are many strategies in here. Some of these strategies can be used for 2D machining options. They work perfectly. We assume that most people will continue to use the conventional Alphacam machining methods for this. So mainly we're going to concentrate on the 5-axis profiling method. So we're required to select a drive curve. This is the geometry that the tool will follow. So we'll pick this contour, and then we need to pick the orientation lines for the vector of the tool. So we're going to select all of these other lines and then deselect the drive curve. The lines ideally should be snapped to the contour that you're cutting, the orientation lines, but if they're not, if they're close, you can obviously set a tolerance here as to how far away they are. Machining side for this, because we're going counterclockwise around the part, we need to be on the right hand side, and we can add an additional offset if we require. I'm also going to go and change my start point, so I select this, and then I can pick the browse buttons. I can either type in coordinates or I can click the browse button again, and it takes me to the drawing to select a point where I wish to start. We can then say OK to these dialogues. I'm happy with the cut tolerance, which will give me a good enough cut quality, and I'm now going to go to the tool axis control. Well, we want it to follow the orientation lines, so this is the line that's being described here. We don't want to tilt away from this line by anything, so we change this value to 0. If we had a solid, we could actually activate also the gouge checking and just get it to gouge check against solid faces as well. And I'm going to come to link, I'm going to add a lead in and lead out. When we're happy with the values that we've set, we can say OK to this, and we see we get our toolpath with our start point where required and our machining of our square corners. However, the one thing that we may notice is that we actually haven't cut through the part. It's the bottom of the tool that has followed the line. So let's just go back in and edit the operation. And if we come to the utility tab, we see that we have this axial shift. This will, if we put a negative value, push the tool through, a positive tool value will make the tool stand off. So if I put in there -3 and then let's say OK to that, we'll see that the tool is pushed through the part further. Now let's look at wireframe machining, but starting from a solid model. So I want to run a trim around this edge here, but I don't have any geometries, so the first thing I need to do is create them. We have the solid, so let's go to solid model extract and use our command edges from face outlines. I want to select connecting lines and outlines only. I'm happy with the chord tolerance, so let's say OK to this, pick this, and then I'll use my face selector to select the trim edges to run all the way around. Let's say finish. What this has given us is the top geometry, the bottom geometry, and hopefully all of the orientation lines in the correct direction, which I will check in a minute. So firstly, we don't need the top line, the tool will follow around the bottom. So let's delete the top line. And just for ease of visualizing the lines, let's turn the solid model off. So we can see we have our orientation lines, but let's turn on our ghost tools to make sure they are all pointing in the correct direction. So if I zoom out, I find that they all are pointing away from the part, which is exactly what I require. So let's go back to our machine tab and select a suitable tool. So let's pick our 6mm flat end again and go to wireframe machining. Okay, we're going to pick 5-axis profiling. Let's select our drive curve and our orientation lines. Okay, I'm happy with the left, but this time I want to go clockwise around the part, and I'm going to pick my start point, and I'm not going to browse for position this time because I know I want to start at the 0, 0, 0 point of the drawing. Happy with the chord tolerance. So let's look at the tool axis control. Well, I want my tool to be in line with my orientation line, so I'll change this back to 0. I'm going to then go to and link and add a lead and lead out. And this time let's remember our axial shift. Say OK to that, and very quickly we get our toolpath. Let's now turn back on the solid and have a look at the simulation moving around that. So as we can see, it's a very easy to use and a very fast and effective way of getting our trimming toolpath. Now let's look at the multi-axis roughing command. So you can see here we have a shaft, and we don't want to waste time machining all this out. The shaft has already been turned, we only need to basically machine this portion out, so there's not lots of roughing that's required outside of this contour. So let's select a suitable tool. So I'm going to go for a 10mm flat end, and let's come to the multi-axis roughing command. Once again, speeds and feeds set accordingly, and we now get the dialog box. Obviously shows us what we're after. So we're doing a roughing machining strategy. Regarding the actual strategy itself, we have three options. Firstly is the offset from the floor, so it looks at the floor surface and then offsets the toolpaths accordingly. We can go offset from ceiling, which will take the top face and basically machine downwards using that as the defined contour. Or we can then go to morph between the ceiling and floor, which starts square in this case and then morphs to the curve of the contour depending on what you have. On my part, my contour is the same for the ceiling and the floor, so I'm going to say offset from floor. At the moment I'll leave the offset strategy as the type of machining. Zigzag is bidirectional, we're happy with that. Any one-way machining would be climb. So we can set here a maximum step over. Once again, this depends upon the type of tool you are using to machine. I'm machining with a flat end tool on a convex surface, so I'm happy to have a reasonably coarse step over on this. And I'm going to change my number of slices to do it in 2 cuts down the part. So we then need to go to the part definition. We now need to tell the system what we want to cut. So we need to go and select the floor surfaces. So I click the browse button, pick the surface I want to machine, say finish, and then pick the wall surfaces. As you can see, I've already coloured in the faces that I want, so now I can use the face selector to say same colour faces. And then let's say finish to that. And then let's leave a bit of stock for a finishing strategy. We have our cut tolerance that we can set. Once again, we still have the facilities for links, roughing, we can set a stock definition, and obviously we have control over the feeds in the utility area. So let's say OK to that. Let's let the system calculate the toolpath that we need. Once again, depending upon the settings and your chord tolerances will depend upon how long this calculation takes. So you can see very effectively we're just roughing around the required shape, and if we look at this in the simulation, we can see that we are effectively moving around the part. So that's a simple basically strategy. Let's just change that now and look at what happens if we select the adaptive, which we more commonly know in Alphacam as a waveform. So the type is offset. Let's change this to adaptive and update the toolpath. And what this strategy is going to do is basically give us a constant width of cut, which allows us to work with a faster feed rate. We're not constantly changing depths of cut depending on whether we're cutting into corners or cutting open features. And we'll see the benefit of this when we run the simulation. So once the toolpath engages, it's constantly revolving around, keeping the same depth of cut that we've specified. So as we can see, it's a very flexible and very powerful method that's reducing any fresh air cutting. We're now going to look at a slightly different way of using the multi-axis roughing. As you can see on the previous part, we obviously had a contained boundary. As you can see on this part, we have open boundaries. So as there's no wall surface to select, we need to give the system a little bit more information to obviously let it contain the machining, otherwise it won't know where to stop. So we need to create a containment. So we've got our solid. Let's take some information from the solid and then we'll have to modify that slightly. So let's go to solid model extract, 3D edge extraction. I'm happy with the core tolerance. Pick one of the edges. Let's rotate the model round. Spacebar activates the last command. Say OK, and we'll pick the other edge. Well, that's got me two of the edges, but obviously I need to find the other ends. Now, what I'm also going to do to allow the tool to come past the end here is extend these. So let's turn the solid off, make it a little bit easier to see what I'm working with. And we're going to go to the geometry menu, and we're going to use Edit 3D Polyline. We're going to extend, and we're going to go by a distance of 20 millimeters. We're going to do multiple ends, and I'm going to do both ends at the same time. Let's say OK to that, pick both of my polylines, pick finish, and we see they're extended. Well, let's use a 3D polyline now to join these so it's a complete closed boundary. On the other end, spacebar, last command again. So we have a contained boundary, but we now need to join these together so it's continuous as well. And let's join our 4 polylines. So they're one continuous one, and now we can turn our solid back on again. So there's our feature to machine. Let's go to the machine menu and select a tool. Let's go for a flat 10 milli and go to multi-axis roughing again. Happy with the speeds and feeds. I'm going to go offset from floor again, offset type, happy with all of these settings. Once again I've got a flat-ended tool, so I'm going to make my step over a bit coarser, and let's go for 2 slices down the part. Let's go now define our part, so we need to pick our floor surfaces and our wall surfaces. Well, as mentioned previously, there are only 2 wall surfaces, so how do I select these other boundaries? Let's now go back to the surface paths, and we have this 3D containment option. So let's pick that, 3D containment curves, pick our curve, so the system now knows that, and cut tolerance. This is a bit of roughing, so I don't need a cut tolerance, that's fine. Let's just put that to 0.1. Let's say OK and let the toolpath generate. Obviously the cut tolerance will affect the speed of toolpath generation and obviously also the quality of it. Obviously it's the same thing, if the finer chord tolerance there's more lines of code, so it depends upon what your machine control is capable of. As we can now see, we've got our toolpath on there, and if we run the simulation we can see obviously the tool is following along there very nicely. Okay, so now let's move on to looking at swath machining. We have a part here that's obviously not a particularly realistic part, but this really just shows off the power of the machining strategy. So let's go and select a suitable tool, and let's go to swath machining. Say OK. So we obviously have many options that we can pick. On this one, just a simple example here, I'm going to go for just picking the swath surfaces. So this is the surface that we're going to machine with the edge of the tool. So let's pick these. We've joined these surfaces so we can pick them all in one go. Let's say finish. Okay, I'm not going to change any other things. We're just going to click OK and see the toolpath that this gives us. So very quickly it's applied the toolpath. If we just go into simulation now and run this, we can see how it's moving around. And like I say, it would be very difficult to machine this all around in one go, but we can just see how easily and how powerfully it's created this toolpath, getting it to follow this swath surface exactly. We're now going to look at a little bit more in depth of the swath machining and some of the obviously commands and that are available within it. So let's go and pick a suitable tool now. So this time I'm going to go and use a ball end taper tool. Let's go into SWARF machining. Happy with the speeds and feeds. Let's go and pick our SWARF surfaces. So I'm just going to concentrate on this one surface here. Okay, we're not going to have any floor surfaces. We'll leave these settings as they are. Happy with the cut tolerance. Tool axis control, we've got all standard things in here. We've still got our gouge checking, link, multi-cuts. Let's just go and add a lead in, lead out in this stage. So let's say OK to that and let it generate the toolpath for us. So once again, it's done it very quickly, but let's just have a look at the simulation on this. Well, I can obviously see straight away that I've got a bit of a problem. So let's just stop that and consider what it might be. Well, I would kind of consider this to be the top line and this to be the bottom line. So I want the bottom of the tool to be along here. And what you have to remember is that all of these faces also have directions, and they have the theory of the top and the bottom. So I could cut that on one face using that strategy and it'd be okay, and on this one it's obviously not. So sometimes we've obviously got to adapt our settings accordingly. So if we come in and edit this operation now, let's say OK, and if I go to tool axis control, we've got this concept of curves. You see there's the top and the bottom. So mine wasn't selected. I now need to select swap curves. So let's say OK to that and see what that changes on our toolpath. Well, it almost looks like the toolpath's disappeared. But fortunately, I'll put the lead in, lead out, and I can see it's just here. So what's actually happened now, if we turn the shading off, the toolpath is actually inside our part. So what settings control that? Once again, we edit, and we have this machining side. Well, auto detect does a good job for us, but sometimes, as we can see, doesn't always get it right. So let's actually look at the settings we have here. We can force left, right, inside, outside, but we have this very nice setting here for the surface normals. So it's actually looking at the normal direction, i.e. outside of the surface or the solid face that we're machining. So let's say OK to that. And we now see we're nicely on the outside. That toolpath looks quite nice now. So let's just have a look in the simulation as to what that's given us. So we're nicely transitioning along the part. So as we can see, it doesn't matter on the shape of tool, things will be adjusted accordingly, but very, very powerful for getting the edge of the tool to run along a face.